Hey guys, welcome to another episode of the Real Hacker Hours podcast. This time I'm going to be doing something a little bit differently. I'm going to be demoing an old tool that I made a while ago. That tool is Remenissions. What it is, it's an autopwner for CTF pwn problems. What that means is you give it a CTF pwn problem and it will generate an exploit for that pwn problem. How it does it? Using either static analysis with the GDB headless analyzer, no, sorry, not GDB, the Ghidra headless analyzer, or dynamic analysis with a little GDB wrapper I made. It will find vulnerabilities such as like info leaks, stack overflows, format strings, check to see if it has the conditions to launch various types of attacks, attempt to generate and then run exploits that leverage those, and then see, oh hey, are any of the exploits that I'm able to generate and run, do any of them actually succeed? It does. Okay, mark that as a successful exploit. So this is the repo for the actual tool itself. Got on tuxedo/reminiscence. Here is the test cases that I used. It's comprised of unit tests that I made myself and CTF problems. This tool has solved over 100 CTF pwn problems, which you can see in here. Like for instance, go in here, Seesaw 18 boy. Here is the exploit for it. Let's also go. Let's check out some return to libc. Yeah, red pwn 20 library. Here's the exploit that this tool generated for it. And yeah, at this time, the type of CTF pwn problems that Remenissions can really solve, buffer overflow of a variable that is then used in some sort of conditional to either read the flag from a file or give you a shell, buffer overflow of the return address to call a function or system if it's imported, buffer overflow of the return address to call shellcode on the stack does require a stack info leak. Buffer overflow of a pointer on the stack that is indirectly called. This right here is just if you have a CTF problem that your input is just called for some reason. Not really anything too exciting. I just noticed there were more CTF challenges than I imagined were solving it was that. So I just decided to go ahead and automate it since it was just too easy not to. And the payoff for that was too great in my opinion not to do. You can this functionality right here isn't so extensive, but I do have support for if you have a statically linked binary that you can with NoPy it can effectively overflow the return address to point to and execute a wrap chain compiled from gadgets from the binary. It can also do return to libc, attacks both where the libc address or the libc leak is provided and when it actually needs to make a puts call to leak the libc address and then leverage that into an attack. Let's see here. Yeah, you can see here it's actually having to like send a payload to leak the address and then parse out the address. Kind of curious if I can. Actually, I'm not going to look for that at the moment. Actually, couldn't resist. So here is an example of an exploit that I generated where it is actually leaking or utilizing a libc leak that is provided. And we check the source code. Yeah, it's actually providing it there. Some of the other attacks that it can do, it can leverage a libc leak on a remote target to do a remote libc ID into a... So I can identify the remote libc version and then do a return to libc attack, and you can also do format strings. But that's enough of that. Let's actually start doing some demos, showing you how what it's like for it to work. So let's go to the first one. Buffer. Okay, let me remove this stuff. So all we have is the challenge itself. We run it. This is a challenge from Seesaw 2018. It's a opponent challenge called Boy. And we can see we run it, asks us Aria, big boy, give some input. Yeah. Let's pass it to Remenissions. And this is just going to be a second of us waiting for it to get done. Right now, this is the Ghidra Headless Analyzer running. Okay, exploit successful. We can see it generated the verified exploit buffer. This Remenissions work, that's just a directory where it stores the files that Remenissions generates as it is trying to solve trying to come up with a successful exploit. Let's take a look at this. See that it's just overflowing a variable on the stack to be this value. Let's try to run this. Okay, we run it. And we can see that the generated exploit from Remenissions is able to solve that challenge. So cool. Let's close out this. Let's go to the second demo. I have 4 challenges I want to demo here. Okay, this is another Seesaw challenge. This one from 2017 called Pilot. It gives us right here, we can see that there's this stack info leak, and the idea is that we are supposed to do a buffer overflow of the return address to point to shellcode on the stack, which we can see the stack is executable. So let's go ahead and run Remenissions on it. This is going to be another probably like 30 seconds or so of just waiting on it. Okay, we're having to run the dynamic analyzer. Reason for that being is how the info leak was presented. The static analyzer couldn't exactly find it, but we see that it was able to find the info leak. So we're running static analysis, and it says it got the exploit. Let's try running it. And we can see here it's able to solve it. Looking at the exploit itself, we can see that first starts out by getting the leak and calculating where there were actually base return address. Yeah, it starts off by scanning the leak and parsing it out, and we can also see that here's the shellcode that it's adding. And yeah, this is just it adding, scanning in the info leak and parsing it out. Okay, that's the second challenge I wanted to demo. The third challenge is a return to libc. And we go to CSL 20. So let's get rid of the existing one. So for this one, Remenissions BROP, we specify the libc2, and let's let it run. Okay, so it says able to generate an exploit. Let's take a look at the verified exploit. Okay, so we can see here that it's having to send in 2 separate payloads. The first payload is to set up a puts info leak, which it then will receive and parse out and use that in a secondary payload to actually execute the return to libc. And when we run this bin dash, we see that we are able to pop a shell. So that's cool. Let's close out of this. And finally, the final challenge I have to demo is a format string. Let me run it. We can see clearly that it is a format string. So let's pass it to Remenissions. It says it's successful. Let's try running it. And we can see clearly here it was able to pop a shell and get code execution. So that's cool. Let's close out of this. And let's take a look at the exploit. Yeah. If this like SF stuff seems a bit weird, that's just my own format string utility that I wrote as a part of this project. But yeah, cool. That's all I have for this time, just kind of a short demo of an Autopwner that I made that I kind of wanted to show on here. Thank you for watching. See you guys next time.